Hello and welcome to Otten Math. In this edition of Otten Math, we're going to talk about inverse trig functions. Right, so our goal is to evaluate all six trig functions and their inverses. So let's talk about what an inverse is. All right, so let's back up a little bit and ask the question, what is the sine of 90 degrees? And that asterisk there is my way of easily typing in the degree symbol. Or what is the sine in radians of pi over 2? So I'll let you think about that for a second. All right, so you should come up with an answer. Sine of 90 degrees is equal to 1. Sine of pi halves is also equal to 1. Another way to look at this is what degree or radian measure gives you the result for sine that is 1, which means if I say sine of some measure or degrees in radians or radians is equal to 1, then what is that value for x? So if we take a look back at what we concluded here, I can say then that the value of the angle or the radian measure that gives me, in degrees or the radian measure, that gives me a side length relationship for sine of 1 is equal to 90 degrees. So we're kind of flipping the relationship for the side lengths and the angle measure, and we're going to conclude or evaluate that as the inverse sine or inverse trig function. All right, so you should come to the conclusion that x in this value in this slide is either 90 degrees or pi halves. Another way to write this function then using the inverse sine nomenclature for math would be sine, and then as if you're writing an exponent -1, inverse, this is called inverse sine of 1 is equal to 90 degrees or pi halves in your calculator. So another way to take a look at this question is, all right, so originally we were looking at the sine of an angle measure was equal to some side length relationship. So you could say that sine 30 degrees is asking the question, what is the side length relationship or ratio of an opposite side to the hypotenuse side in a triangle where the angle, right triangle, where the angle is 30 degrees. And I can take a look at a right triangle that's marked up that way. Side length relationship of sine is y over r. So opposite over hypotenuse. Now, I can reverse or flip the side length relationship value with the degrees or radian measure, and that's what I did in this case. And so this question now is asking, what is the angle measure, not the side length relationship, but what is the angle measure that produces a side length ratio for opposite to hypotenuse as 1/2. And of course, we've already concluded that that is going to be 30 degrees. So what is the angle measure that produces a side length relationship for sine of 1 over 2? All right, so what I want you to do is to go into your calculator. You're going to find the inverse tangent button. Typically, for scientific calculators, there is a second button. You press the second button and then the inverse tangent function, then you're going to press 2. You're going to press n parentheses and enter. Also make sure that you go into the mode section to determine whether or not your calculator is in radians or degrees. It doesn't matter at this point because I'm going to give you both answers. So I'm going to pause here for a moment. Right, so you should get mode radians at 1.107, 1.1 radians for inverse tangent of 2, and degrees at 63.4 degrees. So it says, what is a degree measure when the side length relationship of opposite to hypotenuse is 2? And we're going to say that it's 1.1 and 63.4 based on the values that we're getting, the principal values that we're getting for inverse tangent of 2 from your calculator. All right, so now I want you to use your calculator to evaluate. This is no real instruction here. Simply type in the buttons, inverse tangent 1.2, sine, inverse sine of -0.3, and you can do this in either radians or degrees, your choice. I'll give you the answers for both, or you can do that in both, and I'm going to pause here for a moment for you to complete that. Right, and these are the answers that you should get. I'm not going to spend much time on these values, so just confirm that you have the correct answers. Okay, now I'm going to go on to another set of practice. Now I want you to use I don't want you to use a calculator to evaluate these. You're going to use your knowledge of the unit circle and just a basic right triangle trig to evaluate. So the first one is going to be the cosine of the inverse sine of 4/5. So I'm going to help you with the first one. So I know that the inverse sine is 4/5. So I know that the angle measure, sine of the angle measure, produces a side length relationship of 4:5 opposite to hypotenuse. So if I draw my right triangle, I can see that the value for y is at 4, the hypotenuse is 5, I have a right triangle. So I really have a 3, 4, 5 right triangle, which is a special family of right triangles, or a Pythagorean triple, excuse me. You can also figure this out just basically using the Pythagorean theorem to determine that the value for x is going to be end up being 3. So in this case, we don't need to know what the measure for x is, because now ultimately what we're saying is the inverse sine of 4/5 is x. And then what is the cosine of x? The cosine of x based on this triangle is going to be 3/5. So that's your answer. So it's like a composite function problem using trig values and a right triangle. So inverse sine of 4/5 is x, but I know from the fact that I have a right triangle, the relationship is 4:5, that the relationship of the adjacent side must be 3 to hypotenuse, must be 3:5. So I want you to figure out the rest of the values for tangent, cotangent. The others are fairly straightforward. You can use your unit circle to solve or recall from your memory based on your references with the unit circle. I'll pause for a moment, and then we'll start back up to give you the answers. Okay, so this is just another look at the same problem that I gave to you. Ends up being that the x value is 53 degrees, and if we look at it in this way, sine of 53 degrees is equal to 4/5. The inverse sine of 4/5 is equal to 53 degrees. And then if you were to evaluate the cosine of 53 degrees, approximately you should get 0.6 for your value, or 3/5. All right, so these are the values that you should get from taking a look at the relationships in the first three, and then using what you know about the relationships and inverse functions to get the following values in radians. Okay, that's it. Next step would be for us to talk about domain and set notation, but we're going to pause at this time, and we'll go through that at a later point in time in another chapter. Join us in the next edition of Otten Math for simple trig functions in Chapter 8.